I have a slide here also that are, some of them are not really performing, but I mean, we are still working on it with all the team. But I mean, that's are the, I mean, with the model, we are not able to simulate everything. So this is the reality of the northern of Europe, but we are really working hard to improve these estimations. But of course, I mean, let's say that, I mean, other models are worse.
Okay, thanks a lot. Let's move forward.
Yes, we're running a bit late, but we knew it was going to happen anyway. So now, playing at home, Juliana from here, UPM, Universidad Politécnica de Madrid. The only presentation about ammonia.
Yeah.
It's nice to have.
I'm not. If I'm listening, yeah.
Juliana.
Good morning. I'm going to explain the research that we are carrying. Is the use of an statistical model called random forest. And we want to predict the main factors that affect ammonia volatilization in Mediterranean cropping system. These are preliminary results, so we are still working with them. So first, I would like to explain which is the Mediterranean climate that is characterized firstly by mild wet winters and dry summer seasons, and the main rain events occurs in cold season. So this is a typical landscape of Mediterranean. And why I want to analyze ammonia? That's because a study made in 2017, Maria Cayuela indicates that N2O emissions are overestimated in Mediterranean compared to the ones by the IPCC. So we want to know if this also happens in ammonia, and we want to analyze it. So we know that the N the two main variables that affect the volatilization in Mediterranean system with our data sets is the soil pH and the nitrogen rate. But first I want to see what happens with the lowest, that is the nitrogen application, we didn't expect that because most of the literature says that in order to have less ammonia emissions, it's better to use some techniques like incorporation or injection. So as I said before, this is our preliminary results. So we are going to make another test to see that if it's effectively that the nitrogen application is significantly in our model. So I'm going to go back to the soil pH and nitrogen rate because the model also can make an estimation of how behave the cumulative ammonia emissions if we change the values of the pH soil and the nitrogen rate. So these are the predictions of the model, and says in the y-axis are the ammonia emissions, and in the case of the soil pH, as we expect that ammonia emissions increase while soil pH increase. So although it's not an intrinsic characteristic of Mediterranean climate, for example, in sub-regions of Mediterranean, as is Spain, predominate the calcaric soils. So they are basically with basic soils. So maybe in the case of Spain, which is example because it's the place that I know more, we can be over here. So maybe the pH is really influencing ammonia emissions. So the second one is the nitrogen rate, which says that if we apply 170 and 180 kilograms per hectare, the ammonia will increase drastically. So in places, once again, I put Spain as an example. As Spain, the main crops are rain-fed crops. Those doses are not really used here, and maybe we are in this part. So for our next our next variable, which is emission factor, the top three ranked input variables are, once again, soil pH, crop type, and measurement techniques. And the behavior of each of these input variables are here. I'm not going to go deep in the pH because it's really similar to the last response variable, but I want this to look in this one, which is the measurement technique, and it's basically depends of which is the technique you use, you will have a different emission factor. So it's important to know which is the technique that is going to have the less bias in this case of emissions of ammonia. So in the case of the models, for example, in our database, there was few treatments that use models in order to know how much the ammonia emissions is, and how is the emissions of the ammonia. And in the case of dynamic chambers, which is this one, most of the dynamic chambers were wind tunnels. So as we know by literature, wind tunnels sometimes overestimate the emissions of ammonia. So for me, it's important to have like a protocol or see which are the main techniques in order to have a good results and can make a good strategies in order to reduce ammonia mitigations. So as a summary and conclusions, random forest is a suitable method to predict ammonia emissions. Soil pH is the most important variable that affects ammonia volatilization, but we still not can conclude that intrinsic Mediterranean characteristics influence ammonia emissions. So that's all, and thanks for your attention.
Thank you very much. Do you have questions in the room? Yes.
Andreas Pacholski, TÜ Institute, Germany. Thank you very much. It was a very interesting talk.
Sorry, I think that is a problem with the microphone because...
Okay, I don't know. Is it? Okay, this way. Yeah. Andreas Pacholski, TÜ Institute, Germany. Very interesting talk. Thank you very much. I was somehow also involved in the eventually this ALFAM database. And there we found this confounding of measurement methods and side effects. So I assume it's hard in your data set to get rid of this confounding, that you have specific sites where they have specific measurement methods. And this must eventually also apply to all the other factors, that you have a kind of, you must difficult to disintegrate this confounding.
Sorry, I don't know, I don't get because there is a noise in the microphone.
Okay, just I think you have specific measurement methods which are applied at specific sites by specific groups, and this is confounding, so it's very hard to, but this, to disintegrate, and also this applies probably to other variables which you have here as factors in your model.
That's a problem with the random forest because mainly it's, as is a machine learning technique, they learn with the data set that we have. So as I said, it's a preliminary result. So we are going to have like another test in order to see that if they are the correct and significant values of our data.
That's good. You can also run the analysis, make like 4 data sets, one for every specific measurement technique, and then you see if it's consistent or not.
Yeah.
Marco, please.
Thank you. I'm the speaker before. So are you using also slurry pH? Because actually, I mean, I was a bit puzzled to not see this information. You didn't use organic.
We use organic, but we didn't take the pH of the slurry.
Yeah, because I mean, it's really one of the good point that also Andrea mentioned, that I mean, sometimes the slurry pH is much more important than soil pH because it covers the soil surface.
According to our model, as the fertilized type, we have a different categories in that one. So we take into account for example, the slurry pH or the acidification of the slurry in that input variable. So the nitrogen, the fertilizer type, has inside his input data that information.
Okay, thank you.
Thank you for your presentation. I'm Bao Pen from the University of Melbourne. I just wanted to ask 2 questions about the random forest models. So first is how do you calibrate and validate the model? And the second question is, I noticed that the database you use is relatively small database, like around 100 of observations. So how do you overcome the overfit issues, like considering this relatively small database? Thank you.
Well, if you want, I can talk to you later about how the model works in order to don't have a model overfitting, because what he does, the random, is make a random selection, not only about the input data, but also of the treatments that we have. So these have like 2 scenarios of randomness. So that's the way of the random data works, and is the way that you prevent the overfitting. But you are right, we have a lot of information in a specific place, but when we were looking for the information to put it in our data set, this scarce information of ammonia in Mediterranean systems. So maybe that's an issue also for our model. And the first question, sorry, I forgot which was the first question. No more questions.
I think you can finish this conversation now in the coffee break that we have. It's quite late already. Thank you very much to all the speakers and to all of you. See you. See you outside.
That's fine. It is fine. It's gonna be fine for the next session. Okay, yeah.
One of the largest threats our oceans face today